A soda company fills its 2-litre drink bottles with a mean of 2020 millilitres of soda with a standard deviation of 4 millilitres. Each day a sample of 30 bottles is taken and tested to make sure that the mean is not less than 2020 millilitres, tested at the 1% level. Find the critical region. So we can see that the distribution is normal with a mean of 2020 and a standard deviation of 4. For our sample of 30, the sample means will be distributed normally with a mean of 2020 and a variance of 4 squared over 30. So a standard deviation of 4 over root 30. The null hypothesis here would be that the mean is the same at 2020, and the alternative would be that mu is less than 2020, and that's because we want to make sure the mean is not less. So that defines what our alternative hypothesis will be. The probability that x bar is less than x is 0.01. The 0.01 because we're testing at the 1% level. So what we want to find is this critical value x. Well, first of all, let's work out what the standard deviation is here. So what I need to do is just go to just calculation, and our standard deviation is going to be 4 divided by the square root of 30. And as a decimal, let's make that 0.73. So we now want this x value, so we know a probability and we want a value. So we know that that is going to be inverse normal. So our area is going to be 0.01. Our standard deviation is 0.73. And our mean is 2020. And that gives us 2018.3. And if we just look at this on a normal distribution, here's our critical region here. The mean's 2020 and our critical value is 2018.3. So anything from there downwards would be in the critical region.